So in this video, we're going to talk about how to find the inverse of a square root function and graph it. So remember how to find the inverse of a function? You can switch x and y, then solve the new equation for y. As long as the new equation is a function, you can replace y with inverse notation. Then remember to check for domain restrictions before stating the domain and range of the inverse function. So you can verify whether two functions f of x and g of x are inverses by verifying that f of g of x equals x and g of f of x equals x. So let's start off with this example. You can graph f of x equals x squared and determine the domain and range. Remember, that means you're going to go to your calculator or Desmos and type in y equals x squared. So now this is the graph that you have, f of x equals x squared, and let's now determine the domain and range. So this is a parabola, so they have no restrictions on the domain, so it's going to go from negative infinity to positive infinity. For the range, notice it starts off at y equals 0 and then includes all values of y that are above that. So it's going to go from 0 to infinity. Remember that this is the quadratic parent function. So now let's try finding the inverse of this function. Well, this is f of x equals x squared. Remember, f of x is basically just y. So we have y equals x squared. Then we're going to switch x and y. So we have x equals y squared. Let's try getting the y by itself. So to undo the square, we're going to take the square root of both sides, which gives us the square root of x equals y. So that tells us that f inverse of x equals the square root of x. So now we can graph this function, right? This function f inverse of x equals the square root of x, and we can determine the domain and range. Well, this is a square root function. Notice that the domain starts at 0 and includes all values bigger than that. So the domain will be 0 to positive infinity. The range is going to go also from 0 to positive infinity. Remember that this is the square root parent function. So now let's verify that f of x equals x squared and f inverse of x equals square root of x are inverses. Remember that we need to verify that f of f inverse of x equals x and f inverse of f of x equals x. So let's first figure out what f of f inverse of x looks like. So that means we're going to go to f of x, which is x squared, and we're going to plug in the square root of x for x. So that means we're going to get the square root of x squared, which tells us that equals x. So this part is correct. And now we're going to go to f inverse. So we're going to go to the square root of x, and we're going to plug in x squared. So that gives us f inverse of f of x, which tells us that we are taking the square root of x squared, which that also gives us x. So that is also verified. So yes, they are inverses. So remember that inverse graphs are reflected over the line y equals x. So remember that square roots and quadratics are inverses. So you can see that this line y equals x in gray, that the inverse functions are reflected over that line. So now let's try graphing the square root function f of x equals the square root of 1/2 x plus 1 plus 1. And then you can use your calculator or Desmos to do this, but I'm also going to show you how to do this using the table. So we're going to plug in these values. So we have f of negative 2. So that gives us the square root of 1/2 times negative 2 plus 1 plus 1. So that is the square root of negative 1 plus 1 plus 1, which is the square root of 0 plus 1, which equals 0 plus 1, which is 1. So that's our first value. Then we have f of 0, so that's the square root of 1/2 times 0 plus 1 plus 1. So that gives us the square root of 0 plus 1 plus 1, which is the square root of 1 plus 1, which is 1 plus 1, which is 2. Now we have f of 6, which is the square root of 1/2 times 6 plus 1 plus 1, which is the square root of 3 plus 1 plus 1, which is the square root of 4 plus 1, which is 2 plus 1, which equals 3. And then finally, we have f of 16, so I'm just going to write it up here because I'm out of room. So it's the square root of 1/2 times 16 plus 1 plus 1, which is the square root of 8 plus 1 plus 1, which is the square root of 9 plus 1, which is 3 plus 1, which is 4. So now we can plot these points on our coordinate plane. So we have negative 2, 1, 0, 2, 6, 3, And we can connect these points to form the graph of our square root function. So here's the graph. If you did it on Desmos, you should get this graph. So let's figure out the domain. So you can see from the graph that it's going to go from -2 and then increase from there. So we could say -2 to infinity. You can also figure this out using the domain restrictions. Remember, we want whatever's under the square root to be greater than or equal to 0. So we have 1/2 x plus 1 greater than or equal to 0. So we subtract 1, which gives us 1/2 x is greater than or equal to -1. Then to get rid of the 1/2, we need to multiply both sides by the reciprocal, which is 2 over 1. So we multiply both sides by the reciprocal and we get x is greater than or equal to -2, which is the same thing we've written here with the domain. The range is going to be starting off at 1, and it's going to be all values greater than that. So it's going to be 1 to positive infinity. The reason it starts off at 1 is because that is the value of the function that corresponds when we have that f of -2. So if we plug in that -2, we get 1/2 times -2 plus 1, which is the square root of -1 plus 1 plus 1, which is the square root of 0 plus 1, which equals 0 plus 1, which is 1. So now let's figure out the inverse function, right? F inverse of x. So we have f of x equals the square root of 1/2 x. So I'm just going to write that as y equals the square root of 1/2 x plus 1 plus 1. And then I'm going to switch x and y to find the inverse, right? So I have x equals the square root of 1/2 y plus 1 plus 1. So I'm going to start off by subtracting 1 from both sides. So I get x minus 1 equals the square root of 1/2 y plus 1. And now I'm going to square both sides. So that gives me x minus 1 squared equals 1/2 y plus 1. So now I need to get this y by itself. So I'm going to go ahead and I'm going to expand out that x minus 1 squared. Okay, so remember that x minus 1 squared is the same thing as x minus 1 times x minus 1. Remember that I can use FOIL to expand out these terms, right? I do first times first, which is x squared. Then I do the outsides, x times -1, which gives me -x. Do the insides, -1 times x, which is -x. And then last times last, which is 1. So that equals x squared minus x plus 1. And that is x squared minus 2x plus 1. So I have x squared minus 2x plus 1 equals 1/2 y plus 1. So I'm out of room, so I'm going to continue solving over here. X squared minus 2x plus 1 equals 1/2 y plus 1. So remember, I'm still trying to get y by itself, so I'm going to start off by subtracting 1 from both sides. So that gives me x squared minus 2x equals 1/2 y. So now to get y by itself, I need to multiply by the reciprocal, which is 2 over 1. So when I multiply by 2, I want to multiply every single term in my equation by that 2. Okay, so the 2 over here is going to distribute. So I have 2x squared minus 4x equals y. And so now I finally have my equation solved for y, right? So I can say that f inverse of x equals 2x squared minus 4x. And that is now my inverse function. So now let's figure out any domain restrictions after graphing the inverse function. So you can go ahead and graph this function in your calculator or in Desmos, and you can use that to figure out any domain restrictions. So here's the graph that we get when we graph this function. Notice that it is a parabola. So parabolas don't have any restrictions on the domain, so it'll be from -infinity to positive infinity. The range is going to start off at -2 and include all y values bigger than that. So we'll say the range is from -2 to positive infinity. So notice the pattern. The original function had a domain from -2 to infinity and a range from 1 to infinity. The inverse had a domain from -infinity to infinity and the range from -2 to infinity. So what happens is that the domain of the original function becomes the range of the inverse, right? It makes sense because we swap x and y. The range of the original would be the domain of the inverse, but the difference is the original has some restrictions, right? Since it's a square root function, it's only including half of the values in the range, but the domain of the inverse actually includes all of the values because it is a quadratic function. So let's try graphing the function f of x equals the square root of x minus 3 plus 2 and its inverse, and let's determine any domain restrictions. So here's the graph of the function. So you can see that the domain is going to go from 3 to positive infinity, and then the range is going to go from 2 to positive infinity. So now here's the graph of the inverse. Okay, so the inverse function is what we get when we switch x and y. The inverse is x squared minus 4x plus 7, which is once again a parabola. So the domain is going to go from negative infinity to infinity. And the range, you can see, starts at 3 and goes to positive infinity. So in summary, remember, to determine the inverse of a square root function, you're going to use these steps. You're going to switch x and y, solve the resulting equation for y, and then replace y with inverse function notation. Then you're going to graph the functions and determine any domain restrictions.